Chapter 11, Section 3, Surface Area of Pyramids and Cones. So a lot of vocab here for this section. First off, a pyramid is a polyhedron in which one face, the base, there's only one base, can be any polygon, and all of the other faces, the lateral faces, have to be triangles that meet at the common vertex, called the vertex of the pyramid. Sometimes it's called the apex, A-P-E-X, but this is our vertex of the pyramid. The base can be any shape, and all of the lateral faces have to be triangles. So here we have a hexagonal pyramid, here we have a square pyramid. The name of the pyramid is by the shape of its base. The altitude is the perpendicular segment from the vertex to the base of the pyramid. The height is the distance of that altitude, so the length of that altitude. A regular pyramid is one whose base is a regular polygon and whose lateral faces are all congruent isosceles triangles. So here we have a square pyramid, so a square is a regular base, a regular polygon. So all of these triangles are congruent and they're also all isosceles. The slant height, represented by L, is the length of the altitude of the lateral face. So here you see our slant height, it's literally the slanted height. This is the altitude or the height, and this is the slant height. In this book we can assume, and for this year we can assume, that the pyramid is regular unless it is otherwise stated. The lateral area of a pyramid is the sum of the areas of the congruent lateral faces, so everything except for the base. So basically you're finding the area of the triangles and adding them together. You can use a formula for the lateral area of a pyramid by looking at its net. It's going to be, if it's a regular pyramid, meaning all of the triangles are the same because the base is a regular polygon, it's going to be 4, in this case, times 1/2 of the slant height times the side length. So the side length is S and the slant height is L. This can simplify down to 1/2 of 4S times L, which is the same thing as saying half of the perimeter times the slant height. So this is going to be our final kind of formula for lateral area. So the perimeter times 1/2 times the slant height is going to be for lateral surface area. To find the surface area of a pyramid, you add the area of its base to the lateral area. So like a pyramid, a cone is a solid that has one base and a vertex that is not in the same place as the base. So our vertex is up here, our base is down here. The base of a cone, though, has to be a circle. If it's a cone, then the base is a circle. In a right cone, the altitude is the perpendicular segment from the vertex to the center of that circle, the center of the base. The height is the length of that altitude. The slant height is, again, going to be represented by L, and it's the distance from a vertex, so a point on the edge of the base. So a point from the vertex to any point on the circle, on the circumference of the circle. We're going to, again, assume that it's right unless stated otherwise. The lateral area is half of the circumference of the base times the slant height. The formulas for the lateral area and surface area of a cone are similar to those for a pyramid. So for a cone, the lateral area is going to be pi times the radius times the slant height, and the surface area is going to be the lateral area plus the area of the base, which is always a circle, so pi r squared.